I just want to update some people on some things. So first of all, remember that Mount Cuba is closed due to the fact that we can't really accommodate anyone there. We would like to use the Samhain at some point, but the problem is if you have one person using the Samhain, then another person goes to use it after them, sanitizing in between just isn't going to happen. So we can't really do very much there right now. We may have some star parties at more remote sites where we can socially distance. There are a few places that have said that they would have us for that. So we'll send out details of that to the groups.io. As long as you're a part of that, you'll be able to go. And basically there will be no sharing of eyepieces or anything like that at these events. It's just going to be like, hi, how are you? From a distance. I'm looking at Saturn. You know? But it still could be very cool because, you know, you do get to talk to the people, even though you might be across the field from them. So we would like to get out and do some of those. All of our outreach events are basically canceled until further notice because we can't really do anything. If somebody does want to do something over Zoom, Mount Cuba has been doing several of those. So if some organization expresses interest and somebody's willing to do something over Zoom, by all means do it. We definitely can support that. You could even piggyback on some of Mount Cuba's. They could join some we organize, you could join some they organize. We can work together with them. So we could do outreach, just nothing in person for the foreseeable future. Likewise, all of our upcoming bigger events are basically canceled until further notice, but we will continue to have the astronomy workshops every Tuesday at 7 p.m. We'll continue to have our monthly meetings every month, third Tuesday of the month, 8 o'clock. We'll continue to have our board meetings every second Tuesday at 7 o'clock. And we'll continue having our AP SIG meetings, which will be sent out over email from Bill Hanagan, and our book club meetings. Amy will inform you of those. So you just keep your eyes open, and if you're going out to do some observing and want some other folks to come out, just send a message on groups.io and they can join you, and you can socially distance and watch the stars together. So that could be very nice. We do have several people lined up to speak this evening. Jeff said there's at least like 4 or 5 people that are ready to go with some good presentations. So we'll get to those in just a second. Any other key announcements? All right, remember the details from the previous Zoom talks. We will be muting everybody except the person who is sharing their information so that we don't get a lot of chatter and noise in the background. If you have questions, feel free to use the chat, or if they're okay with it, you can just press the space bar and chime in if they're okay with that again. But definitely the chat is always good. All right, Jeff,
can I say something real quick?
Oh, certainly. Hi.
My name's Vic Leonard. I'm running the astronomy club at AI DuPont High School. We have a couple of our members on here today. Got invited by Dave. So we're going to try to have a partnership with you guys again. We did a couple of years ago. So I think Grace and Kathy are on here. They'll be part of our astronomy club. We'll try to do it virtually until we get back to school. So anything you guys can do to help us with that, with Zoom meetings and so forth, that'd be great. Appreciate it.
Oh, yes. Speaking of that, are there any other guests or new members that want to introduce themselves? That's a good idea.
Nobody else wants to pay $30.
Oh, we do have like 108 members right now.
This is John. I don't know if I'm on mute or not. This is John and Linda Osenak. We're from Newark, Delaware. New members. We've been playing with our little miniature telescope and binoculars and sky watching and trying to learn the constellations and the planets in the sky.
Very nice.
So hello, everybody.
Great.
Hi, that's great.
Welcome, welcome, welcome.
Awesome.
Welcome.
Welcome.
Thank you.
Hey, Rob.
Yes.
For news of Mount Cuba, we did get the building permit and construction on the telescope will begin or has begun I know they delivered the porta potties, which were most, that's extremely
Well,
important.
that's significant.
But we're hoping to have a groundbreaking ceremony sometime in October.
Okay.
But the project is officially underway. There have been a number of sections of the telescope that have been completed, including the pier. So, within 2 years, Mount Cuba will have a 1.3 50-inch telescope out back. It will be the largest telescope on the East Coast.
Fantastic.
Yeah.
Congratulations.
Yeah, that's
Thank you.
fabulous.
Awesome news.
I didn't know there was that much progress. The pier's done?
Pier's done, part of the telescope's been done. It's
That's
amazing
fantastic.
when you start throwing large sums of money at people, things can happen.
Yeah.
Unfortunate that Newcastle County took more than 6 months longer than what we thought they would to give us the permit to
With the
break ground.
permits?
Yeah.
Oh, yeah, naturally.
Yep.
Dang, planners.
6 months?
6 months longer. Yep.
Wow.
Okay, it's exciting.
It is.
What
Yeah.
kind of cameras, David, is there going to be some camera equipment with that? I assume so, or?
Yeah, we're evaluating, right now we're evaluating a Lakeshore CMOS camera.
Mhm.
Cool.
So there's gonna, it's a Ritchie Creation. I believe it's F6. So it's a fairly fast Ritchie Creation.
Yeah, you're not kidding.
Also going to get a spectrograph with it and a bunch of other equipment. So yeah, it's going to be totally automated. So it'll be on the web. So it can be controlled from any place in the world.
Ah,
Awesome.
this is so exciting.
Including Elton.
Excuse me, Rick?
Any place in the world, including Elton, I hope.
That's right. That's right. As long as you have the right codes to sign in the passwords, yes.
All right.
Any other new members want to announce themselves and tell us about who they are? I think that's it. Any other announcements that were missed? I think that was basically it, because we don't have any outreach. All right, Jeff, continue with the main program.
All right, so before I jump into tonight's program, just want to give a couple of words about the intentions for this season. It is anyone's best guess how long this quarantine is going to go on and how long it's going to take until we can get back together and start to resume gathering up at Mount Cuba. But my intention is for this season is to maintain monthly programs every month, at least through June. We did that for, I don't know, a third to half the season last season. In fact, we took our normal 2-month break, which actually ended up only being a 1-month break because we had normally we take a break during July and August and then resume in September, but we actually had a bonus meeting in July, thanks to Rob. So we'll see how it goes. I'm not trying to think about June, July, or August at this point, but my intention is to fill every month with programming as we normally do, with a mix of outside speakers as well as a couple of months where we do a series of member mini talks. So a couple of things to note there. Think, as I will start, at some point to solicit for member mini talks, that if you have something you'd like to share, that would be fantastic. And I mean, don't feel overwhelmed by it. It could be a 2-minute presentation. I kind of like to keep the member talks capped at about 15 minutes. And as you'll see tonight, you could use PowerPoint. You could simply do a little series of photos, or you could do mad scribbling on a whiteboard, Dr. Spencer. or just tell us a story, tell us a tale. My point being is, don't let any technological anxieties prevent you from sharing. If you just wanted to get on Zoom and tell us a story or say something, that would be welcome as well. So again, I'll probably pepper in a couple of months of member mini talks, so keep a lookout for that. And then the other one is, as I said, I am the programming chair, but that I try not to operate as the dictator. I certainly welcome suggestions. if someone knows a topic, or even better, a speaker that they would like to have come join us, please let me know. I sort of see this quarantine as some good and some bad. Obviously, I don't need to state the bad. I think we've all figured that out by now. But the good is people are largely at home, and actually scheduling is a bit easier now because people are not traveling and all that. Plus, now that we've got this Zoom thing down pretty good, we've immensely opened up the world of possibilities in terms of where speakers can come from. Prior to this quarantine, I think we had done 1 or 2 remote talks via Zoom or Skype, but we're really getting the swing of it now, so that greatly increases the possibility for speakers that we have. In fact, a little sneak preview, I think it's our February talk, will be a professor from Berkeley. Normally it would have been prohibitive to fly somebody out from California, but due to the magic of Zoom, we'll, so my point is, if you have an idea, share it with me. Even better, if you would like to break the ice and reach out to somebody to gauge their interest or willingness to give a talk, by all means, break the ice. All I ask is when it comes down to the specifics of then finally scheduling which month they would share, at that point, bring me into the discussion, because obviously I'm trying to juggle and balance lining up the talks throughout the various months this season. Intend, again, have programming every month. I'm going to hold off a bit for our May meeting. That's typically our dinner meeting. Not really sure what May is going to hold for us. So I'll probably start thinking about the dinner meeting maybe towards the beginning of 2011, just because if there's a chance we could hold a dinner meeting like normal, that would be great. If not, we'll just hold a normal Zoom meeting. And I'm still thinking about December. December is also typically a unique meeting where we often have our holiday party, where we've not typically had speakers, but we get together at the observatory. Usually we have a potluck and just kind of gather and chat. Not sure that obviously is going to work as well. That sort of seems like what we're doing on our normal Tuesday workshops. So December might just turn out to be another regular, speaker lecture-driven meeting. We'll see. And if anyone has suggestions, again, please let me know. My intention is to fill out the season all the way through June as soon as possible. It kind of just takes that weight off my shoulders. So again, any help, meaning a talk that you yourself would like to give, or again, if you know someone from outside the club that might be, we're always looking for unique topics, a topic or an angle of astronomy that maybe hasn't been covered by a talk so far. Any questions about all of that?
Good.
And again, I'll be emailing to reinforce a lot of those comments. So that brings us to tonight. Again, we have a series of member mini talks. And as Rob said, I think what we would like to do is to mute everybody just to make sure that the audio is as clear as possible. Obviously, we will unmute each individual speaker as they're prepared to share their content. If you have questions, the first preference would be to put a question in the chat section, and Rob and I will be monitoring the chat, and at appropriate moments break in and ask the questions for you. That way we just don't have a cacophony of different people talking at the same time. Like that. Maybe what we'll try to do is after each individual speaker, or maybe at the very end, we'll just open it up and allow people to freeform ask questions. But during the presentations, we like to preserve the audio, and so prefer to keep everybody muted.
1 second, Jeff. I'm going to press mute now.
Yeah, so, yeah, go ahead and mute everybody.
Now you can unmute yourself, Jeff.
So to start off for tonight, Ron Worden is going to share about some recent upgrades he did to his backyard observatory. Ron, all yours, man.
Okay, I'll try to put this on correctly this time. You got it? Can you see it? Okay, I moved from my previous house in Broadfield in 2013, and instead of taking my other observatory that I made with me, I kind of just put it aside. And when I got to the other one, I got a sky shed from Stolfus's up there in Matlab, Pennsylvania. And it's a roll-off roof instead of a roll-off building. I'm not keen on 7-foot walls. I think they should be closer to 5 foot. But anyhow, being as it may, I just instead of I just put in a floor, a 12-inch floor to raise it up, because this is only 42 inches here. The pier that I originally had at Broadfield is 42 inches. Well, that's all well and good if you got $1,000 or $2,000 you want to waste and put on another 4 or 5 foot, 5 foot or 6 foot pier, which I didn't. So anyhow, I put in this and I put it on a tripod, which was a mess, or it was satisfactory. But I mainly wanted to get my observatory set up remotely as quickly as I could with Rob's help, of which was greatly appreciated. And so now it's running remotely, and I was operating from about 2014 till now remotely on just a Lost Mandy tripod. So now then I decided, okay, what I did is I dug up my floor here, got down to the base, and I dug a 18-inch square hole 30 inches deep. And then on top of that, I put a frame in. It was 27 inches deep to build it up up high enough to peek out the top of my shed. So anyhow, it's 18 by 18 by 30 inches, and plus the 27, so it's 18 by 18 by 30, 40, 50, 57 inches. It turned out to be, it turned out to be several cubic feet of concrete. So I ended up calculating it out to being about, well, it was 18 bags of 50 or 80 pound bags of concrete. But it calculated, because it wasn't a perfect hole, it calculated out 15 80-pound bags of concrete. So what I did is I put the wheelbarrow here, and a friend of mine helped me mix it up one bag at a time, and then I just shoveled it into the hole. So the next slide is this here is the template with the rods. And my originally rods that came with the pier, of which are back in the old hole at the previous observatory, they were hooked around like this, but I couldn't get those kinds, so I put washers here so so this doesn't loosen up in the concrete and come up and down. So I put washers there. And this is the template here. And then the next thing, I filled it up, and there it is there, all ready to go. And then I mounted the pier on that. So it's basically done. And it wasn't enough concrete to really have it brought in, which it would cost effective to just only bring less than a yard of concrete in. So, and that's it, ready to go. And it's finished there. And of course, I got a bird's nest here of I'm going to have Rob help me to do some wire reconstruction to make it less sloppy, and it looks horrible, but I want to get this all straightened up here. Eventually that'll take place. So I got my 10-inch here. This is my wide field scope here, 102 refractor. This is my guide scope. This is my ZWO camera, solar scope here, the camera for the this ST 2000 color camera there, and this one back here is the ST 2000 with the filter wheel. This is a one-shot color here, and this is a filter wheel here. I just got a CFW 10N10 for 10 filters. So this is the narrow band scope, and this is the broad band, and that's it there. That's it. Any questions?
So I didn't see any questions come through in the chat, but if anybody has one, feel free to unmute yourself and ask Ron.
Great job, Ron.
Thanks.
Yeah, Ron, that is really awesome. That's great.
Thank you.
Great, Ron. Yeah, we can help you with the wiring if you want.
Yeah, I need to get a block for the wiring, but
Yeah, you can probably move most of those wires out to the scope itself and just have like 1 or 2 wires going back in the observatory.
right.
Cleaner.
I don't use the warm room that I put in too much anymore. I just use that for the large scope there for visual, and the large scope I use for visual, for getting warmer or cooling off or whatever.
But why don't you use the warm room?
Because I don't need to. I come inside. I go out and I flip the switches and and turn everything on, and then I come in and just connect everything to my laptop and run it from inside. I don't go out again until I close it. I only use my my warm room for the large 14.5-inch Dob there, which I do visual, and you know, for getting out of the mosquitoes or getting me cooler or warmer or whatever. But but the warm room's always handy for books, to put books in and things, store things carefully. And I also I run my wires in through a hole to the my Raspberry Pi, so the Raspberry Pi is inside of the warm room, keep it out of the elements. And I do run my my Dob from the source there, from the controller there into the warm room to my computer, and just to be able to I got it connected up so that I can run it by the computer, digitally skew it, run it from the computer in there, so I can use a planetarium to make the Dob go to where I want to, and then I just go out and look at it and enjoy visually, and then come back in and push another button and it goes to another spot, and I come back out and look at it and go back in that way. So it's done that way. That's what's nice about the warm room, that with that. But with my with the main setup, I just want to run it from inside my house. I just go out and flip my switches, and I had a year or so ago, my roof, as you saw, is connected to a garage door opener, and the chain came off, and I had a hard time keeping the chain on, so I was doing it manually, rolling it off. But I just had Stolfus come out and do maintenance on it, just a bit of update maintenance, and they put the chain back on it, tighten it real tight, and it's working perfectly now, going off easily with my garage door opener with it. It's not manual anymore. And they were kind enough to say that anytime I need help, they'd come out. Of course they charge, but it's not very much. It's a reasonable price, so it's worth the while. A yearly type, or every year and a half checkup on it. So. Any questions?
Yeah. Any final questions for Ron? Did I? Rick, if you were saying something, you're muted.
Yeah, I just was asking, Ron, how often you get out there?
Every time there's a clear night,
Okay.
or that I'm home. Sometimes, well, as you know, the nights are not very good, and then it'll have the clearest night is during the moon, a full moon, and that's not very happy.
Yeah.
So every time there's a clear night, I go out. So, you know, sometimes I just go out and I go shoot around the sky just for fun and look around and don't take any real serious pictures, just look around. Or I go out and look through my, the Dob. But most of the time I do try to take pictures with it. But,
Nights with the moon are why they invented narrowband filters.
I'm sorry?
I say clear nights with the moon are why they invented narrowband filters.
Yeah, that's all well and good, but then you can only go so far because some of the dim objects you can't get very well either.
Well, hard things are hard.
Yeah, well, it's a lot easier when there's no moon. So, but yeah, I know what you're saying. The narrow band is for that, and I agree, and that's where I do take some pictures anyhow. But I also know that there's some dim objects that are narrow band too, but they're especially when the object is near the moon itself.
Yeah.
Yeah, that's still you know. But anyhow, most of the time I get out when it's clear.
Cool. Again, thank you, Ron. Thank you very much. Great presentation. Thank you for sharing.
Thank you.
So Rick, maybe we'll do a tag you're it, and I'll save you the trouble of having to remute yourself. Would you like to go now?
I'm just trying to finish a plot. Let me see if it.
We can give you a few minutes, no problem.
Yeah, I'm just trying to make a. Yeah, let me give me a few minutes. I'm trying to label the diagram that I was going to show.
Sounds good. Matt, are you ready?
Yeah, sure.
All right.
All right, so I will share my screen.
So Matt Bobrowsky is going to give us a presentation about teaching astronomy in India. It's a very intriguing title, so curious to see where he goes with that.
Yeah, and I'm cheating a little bit because this is supposed to be about what I did over the summer, and it's actually what I did the previous summer. So, but that's okay, since I haven't told you about it yet. Let's see if I can let you see this.
I'm sorry, Matt, you violated the rules. We cannot allow you to talk.
Okay, well, go on to the next person, I guess.
No, it's all good. It's all good. I believe the title is What I Did Last Summer. So, you know, technically that was in the past. So I think it works.
Okay, why is that?
Yes, in the English language, last is a rather ambiguous term. It can refer to the one that just happened or the one that happened before that.
Right.
So
Right,
do you see a map?
Not yet.
No.
You do not see a map. Can you tell whether I'm sharing my screen?
I don't believe you are.
We're not sharing your screen.
Okay, I thought I clicked on that, but I'll do it again. Hang on. Okay, share screen. I think I see what's happening here. I think it wants me to select an application.
You need to select the screen to share.
Yeah.
Okay, it's showing me all my windows, which are many.
So Matt, you have two options. You can pick the specific window, like if you have a PowerPoint, you can pick the PowerPoint window, or what sometimes is easier is I think one of the choices is just to share your entire desktop, and then whatever, oh, there we go, something's happening. We see a map.
Okay, great. So last summer, a year ago, I went to India to teach astronomy to some Tibetan monks. And that was an interesting experience. So I'll just say a few words about it. So you can see where I was in India, and we could zoom in on the area. Oh, wait, I can go to slideshow. That's what I should do, right? My computer's slow, and it's a little worrisome. I had the spinning beach ball for a moment there. Stand by. The spinning beach ball. Okay. So I was in this monastery, which is so kind of, in a way, it's sort of in the middle of nowhere, but there's a small town not too far away. Nearby, you have the restaurant with no. This is the first time I saw this on a Google map. I just thought that was interesting. So I thought I would have very primitive accommodations, but actually they're quite reasonable. This is basically sort of a dormitory type place where I stayed while I was there. And my bed had mosquito netting. Looking out the back window, there's this field. This is actually a monk reading there, studying or whatever. There are hundreds of monks in this place, but somehow he got that whole field to himself. So here's what it looks like in the classroom. Let's see, I want to get rid of these. Hide self view. Oh, okay. I'm trying just hiding all your thumbnails. Okay. I don't know if you, well, we'll see it better a little later, but my slides were somewhat translated into Tibetan. So, and I would speak and then say a sentence or two, and then the translator would translate into Tibetan. Here's what the classroom looks like. They take off their shoes before going in. This is a nearby big temple within walking distance. A meditation room, which on the inside looks like this. The person leading whatever is going on would sit up at the front in the lotus position. No one was in there when I was there, so I figured, well, I could go sit down there, and so I did. And that's basically how they sit all the time. So, oh, and you see they have these, I gave them these little cards with A, B, C, and D so that they could answer multiple choice questions without my having to learn Tibetan. I'd label the four answers, A, B, C, and D, with different colors. And here I have them working on a group activity. Here's the, they're making an HR diagram here. Everybody had a few stars to add to the diagram. Feel free to interrupt at any time if you have any questions. So that's
so
my
Matt,
yes.
I'm not sure if you're planning to address this, but what was the, how did this start? What was the nexus of this opportunity?
Oh, well, So I saw in the email that Emory University had created a partnership with the Dalai Lama and the Tibetan monk community to create science programs for them. I don't know if you're aware, but the Dalai Lama is actually very interested in science and recognizes the great value of science, which is maybe a little unusual these days for leaders to feel that way, but he's very enlightened like that. So anyway, they created a partnership, and Emory University put out a notice that they were soliciting scientists. So they were teaching astronomy, biology, chemistry, etc. And they were looking for 2 astronomers from anywhere in the US. And I applied, and many other people applied. And so I ended up going, and one other guy named Michael Gregg from University of California at Davis. We might see him later. And the 2 of us went there for 2 weeks. And we basically presented an Astro 101 course for them.
So I don't, are you an astronomer or a?
Well, yes, I have to admit I am. And, so I'm currently teaching astronomy at Delaware State University.
You're a faculty at Delaware State University?
Yes.
So Matt, what was their like base background level of knowledge? You said astronomy 101, but can you go into that a little bit more? Like how basic did you have to be?
As with my students that I normally teach, I assume that they know pretty much nothing to start with. In fact, it's worse than that. My students typically have lots of misconceptions. So I'm not starting with blank slates. I'm starting with wrong information. And so I have to, and by the way, anyone who teaches probably knows that, misconceptions are very persistent. And if you don't address them directly, they will continue. Even if you teach the correct information, people will continue believing what they believed before. It's actually very difficult to change the way people think. You may have noticed recently. Okay, so here we can get a better look at how on the slides we've got both the English and the Tibetan, and so that worked out very well, actually. Oh, that's the other astronomer there on the left, Michael Gregg. That's the translator in the middle. He was very good, actually. He could do all the technical terms and everything. So that was great. Oh, so question? We are doing a spectroscopy lesson here. You can see everybody's wearing their diffraction glasses. And here they're building spectroscopes out of cardboard. These were very good students, by the way. Better than students I've taught mostly in the US. They're very engaged. They're interested in learning. They ask good questions. It was really lots of fun teaching them. Oh, so this is a, let me see if, tell me if you can hear this video. If it doesn't work, then I'll just narrate the next one.
So one of these factors is the mass of the object. Does the mass change and it contracts, yes or no?
Can you hear the audio?
Yes, I can.
They mostly say no. Right.
Okay. One more video clip. Here I'm doing a demonstration of conservation of angular momentum. So I asked for a volunteer. The only weights I could find were microscopes.
You must not drop these. So, you can relax for a moment while I explain. So when you try this, you'll start with holding them out. Then I will start you rotating. And after I let go of the chair and you're spinning, then pull them in all the way to the center. And everyone else should watch and see if he speeds up as he pulls into the weights.
He doesn't do it right the first time, so we have to actually try it a second time to get it to work properly.
So experimentation like this is an important way in science that we test our ideas and see if they are correct or not. Are you ready? All right, so you can put them out. We'll start you spinning. Okay, now hold them into the center. All the way in.
See, he doesn't pull them in far enough. And then it's too late. So we try it again.
This time, pull it all the way in. Okay, we'll try it again. That worked very well. You did a great job. Thank you very much.
Let's see. Oh yeah. So one day the snake made an appearance. Does anyone know what kind of snake that is?
Is that a python?
No,
It's not a python.
not a python.
Uh-uh.
A cobra?
Too slendered bodied
Yes.
and too
Who
small.
said cobra?
Head.
Sid.
Cobra is correct. It is a cobra. So when they find a cobra, they have to catch it, and then they put it in a tube. They get it to go in a tube, and then they take it away in this tube and release it out in the woods somewhere. Okay. Meanwhile, my students are doing scientific experiments. Here I think they're doing a parallax activity and comparing the measured distance to what they determined by a parallax measurement. So lots of astronomy activities. And then, oh, they had a couple of dobs out there, so pulled one out every so often and would let them look at things, typically bright things like the moon. It wasn't as dark as I had hoped because of the artificial light around the monastery, but we were able to see a few things. So that was really nice. And many of them had never looked through a telescope before, so that was a great experience for them. I think it's always great when you can see things that you had never seen before. At the end, we were presented with awards. That thing around our necks is, I don't know, some honorary garment that they gave us. And we had given this certificate. And this is the group, these are my students. And these are students from all the classes that were there, all the different science subjects. So pretty big place. Okay. I've stopped sharing, I believe.
Very good.
Thanks, Matt.
From a year ago.
Wow, that was fantastic.
Hey, Matt. So I know the Tibetan situation is very complicated, and without getting overly political. So you were in India, but these were not ethnic Indians; these were Tibetans, right?
That is correct.
Can you talk a little bit to that?
Yeah. So you might think that Tibetan monks should be living in Tibet, right? But sometime around 1950, China invaded Tibet. And by around 1959, the Dalai Lama fled to India. And so a lot of Tibetan monks now live in India because the Chinese does not make them feel very welcome, to put it mildly.
Yeah, they're tortured.
So like, would these be people that were born in Tibet and moved in India, or maybe is there a big enough Tibetan community in India that they're?
They're both, though. So there are some of the older ones who came from Tibet, and then there are. I saw some Tibetan monk children there too, so they are keeping the community going somehow.
Gotcha. Now, were you living in the same type of accommodations that the monks were living in, or did you have a special housing?
So I had a special, like visitors dormitory room. It was very comfortable accommodations. I didn't know if I would have electricity or anything, but I did. I had electricity, had internet. There were fairly frequent power outages, but they didn't last too long. So we were usually be able to get back online before long. Yeah.
Matt, the videos over the streaming, at least on my end, were a bit choppy. Our intention is to post this whole Zoom video on our YouTube channel. If you'd be up for it, you could share those two videos with Rob and he could put them directly on the YouTube channel. That way, after the fact, people could take a second look at them where they would stream a little bit more smoothly.
Sure, be happy to do that.
Great, thank you.
I'll include the video where the Cobra was being captured too.
Yeah.
I'll splice those in.
Awesome.
Excellent.
Any other questions?
You did answer all the questions I saw in the chat.
Matt, I have a question.
Yes.
These are religious people. Did any of your teachings conflict with any of their teachings or views of the world? I mean, you would look at what they did to Galileo and things of that nature in the past. Was there any issue with that?
Well, they did not put me under house arrest, and I didn't get burned at the stake. So, but actually, that's a great question because that's actually more of a problem with my students in the U.S. than it is with the Tibetan monks. They have some beliefs that that I would not ascribe to, you know, maybe related to reincarnation or something like that. But they are okay with ideas like biological evolution. I talked about the Big Bang, and Ron, are you shaking your head? But you know, when I talk about the Big Bang, I put it in a non-religious context. You know, I talk about it in terms of what we observe, right? We observe the universe to be expanding, you know, and if you have something expanding like an explosion, it had to have a start. You had to start expanding at some point, and we give that a name, the Big Bang. But the fact that it's just the start of the expansion of the universe, there's nothing really mysterious about that. And there's nothing atheistic about it, about saying that the universe started expanding, you know, at a certain time in the past. So that was not a problem, really. And we didn't really get into any religious disputes, which was very nice.
Good, thank you.
Now, Matt, you said you were there for 2 weeks. Was it a 2-week-long seminar?
Yes. So actually, to tell you a little bit more about the program that Emory University set up with the Tibetan monk community, it's a 6-year program, 6 summers in a row, where and the astronomy is actually the final 6th year in their studies, in their scientific studies in this program. So so they were at the end of 6 summers of learning science, which I think is really remarkable for a community like that to take on. But they are very interested in learning, and they're very interested in knowing the causes of things. You know, they deeply accept cause and effect, and our ability to understand causes based on observations and experiments. So it was really cool that they are open like that.
Cool. Thanks again, Matt. Obviously, if then people have questions, and to any of our speakers, if people have questions later, by all means, feel free to email offline directly, or start up a discussion in the groups.io.
Yep.
I think that could be really cool. So just the last chance, are there any final questions for Matt?
I see in the chat someone asked how the food was. I've actually got about 20 slides showing the food, but in the interest of time, I'm not showing them now. But if you want me to set some later date, just let me know. We can have a special food session, astronomical food.
Cool. All right. Well, thanks again, Matt. That was really interesting.
Yeah, you're welcome. My pleasure.
All right. Dr. Spencer, are you ready now? You're muted.
I know, yeah, sure. Okay, well, this is going to be, so Jeff, you know, since we've all organized things, and when someone asks, oh, would you give a presentation, you think you really want to be helpful, because otherwise you're left with nothing. So the standards are low, and I expect to meet those standards. So basically, this is, my understanding of this is how I spent my summer vacation. That's the topic, right? So interesting or not, I'm going to tell you how I spent my summer vacation. So I decided to read an astrophysics book because I like imaging, I like visual observing, I like chatting with people about astronomy, and I especially like the food part, but I also like astrophysics, physics in particular. So anyway, I got this book by Carolyn Osley, which is called The Big Orange Book in many universities. It's sort of a junior, senior level undergraduate book, probably more junior. And it's a big thing. It has approximately 1,276 pages. And it's kind of, you know, college level, university level physics. That's not too legible, but there's, you know, there's some elementary differential equations and solving radiative transfer and various equilibria. Anyway, so it's kind of fun stuff. And so that's how I spent my vacation. And I want to just show a little bit about that, which will take me, how do I do this? So I guess this is partly, am I sharing this? Yeah. So this is just, I don't know if this will inspire anybody or not. That's the point though. So it's a very fun book, and I went through the first half of it so far, then I got sidetracked. But you know, it starts from nothing and goes to very descriptive things. As you can see, spectrum stuff, special relativity, and then the nature of stars. I just found this whole section incredibly interesting. And again, there's some nice physics in it, but all the stuff you read about and we talk about, you know, it's very, very fun, I think, to get into the physics of it a little bit. I'm not gonna, you know, go through this in any great detail or anything, but in any detail whatsoever. I'm just gonna show the table of contents. But for example, classification of spectra, formation, you know, how do spectral lines form? We know what they are. How do they form? And then that goes into the Hertzsprung-Russell diagram in some detail. Depends a lot on how stellar atmospheres are made. And it's just interesting because you get the interplay of temperature and emission, absorption, you know, density, et cetera. And there's certain equilibrium equations that have to be set up. Interiors of stars are different, but similar. There's still equilibrium equations. The equation of state is very important, meaning how are the various parameters essentially related to each other. Then there's some nice stuff on model building to sort of lead you through building your own star, which I'd like to give a DAS presentation on one day, probably when we're back in person. And there's some computer codes provided at the website for the book, which I haven't yet implemented, but you can actually build a model based on the basic equations. There's sort of 4 or 5 fundamental equations of stellar structure. So it's really quite fun. The sun obviously is the most well-studied. It was just, again, how I spent my summer vacation, this was it. And it was really a blast. Interstellar medium. And then massive stars, we love all this stuff, supernova, different kinds of supernova. There's basically 2 kinds, et cetera, et cetera. They make gamma ray bursts, perhaps. What happens when big stars die, white dwarfs, and the physics of that, neutron stars and pulsars. So white dwarfs, neutron stars, pulsars covered here. And then there's a nice chapter on very general basics of general relativity. There's very few equations in this, but just starting from the equivalence principle, showing it's a sort of, I think, a very, what's the right word, sanitized version of how these things happen. Textbooks are always like that. You know, real science is a big mess and you go the wrong direction and then you think you're right and you're wrong and you think you're wrong and you're right. And it's a big mess. So general relativity is presented sort of as an almost trivial exercise, like, well, if this, then this, then this. But it's more complicated. Nevertheless, it's very, very cool. So with that, that's largely how I spent my summer vacation. But as I mentioned, I really like the stellar structure stuff. So I'm going to stop sharing and go over to stellar structure. And I found these 2 very, very cool websites from the Harvard Center for Astrophysics. I think they're very well known. And you can play with these. These allow you to use pre-existing code developed by smart people who put it online. They've written papers that are very well referenced. And you can do things which I'm going to show you, like developing isochrones and evolutionary tracks. So an isochrone is, if you take a whole bunch of stars and start them on the main sequence, you call that the zero-age main sequence. And what does it look like in, let's say roughly 100 million years, give or take? So what you get when you play with this, so I had to learn a little bit of Python for this. I would say terrible, roughly. But you can make some HR diagrams with the data from the website. So you just write a Python code. Well, I shouldn't put it that way because I struggled with this. Maybe Rob, Lancaster, others could just write it. I couldn't just write it. I had to have a lot of grief and B for this. Anyway, so these are the isochrones 5.5, 10 to the 5.5 years, 10 to the 8 years, 10 to the 10th years. And if you remember your astrophysics or astronomy lectures, and certainly the book I just mentioned, they talk a lot about how as a stellar population ages, gradually the stars move off the main sequence. So everybody starts as a big mess. They move on the main sequence when hydrogen starts burning in the core. They live there for most of their life. And then after a few billion years, okay, hydrogen's all gone and they move off. So these are what the isochrones show. And there's nothing new here, it's just very cool. So I did these 3 isochrones, again, a uniform population of the 0 age main sequence, and then how they look 10 to the 5th, 10 to the 8th, and 10 to the 10th years later. And you get something like this right here. So this is a very poor mess. I mean, I couldn't label things properly, but this is about right.
Rick?
Huh?
Rick, are you sharing something?
Oh, I hope so.
No, sorry.
Oh, thank you. I'm gonna have to start all over.
We saw the table of contents, but then when you
Did you see my slides?
No, the last we saw was the table of contents from the book.
Oh, wait.
Sorry.
Wait. Did you see this slide?
No. Sorry, I meant to cut in earlier. I couldn't quite tell if you were intending to be sharing something or not.
Yeah, did you see this slide?
No.
Oh, okay, well, I'm not gonna belabor everything because that would be deadly and I'd make nothing but enemies, but which I have enough of already. Anyway, so this was, yeah, this is what I meant to show. So this is Carolyn Osley. This is how thick it is. This is how many pages it has. And this is a typical page. So there's various equations in it. And then I showed the table of contents, but this is what I meant to show. Sorry for my poor Zoom skills, but that's what you get for free. Then the second slide is this one. I was mentioning this very nice website from the Harvard Center for Astrophysics. Then I was talking about isochrones, so I'm zipping by this mercifully. So this is a Jupyter notebook from Python, and again, it's like science. It looks like I just wrote this down because of my acknowledged brilliance and ability with Python, but actually this is a complete disaster, and it took me, I don't want to say how long it took me to figure out how to do this, but anyway, this is the sanitized version. So I was talking about isochrones and how I think I described those verbally without showing any pictures. So I'll show the pictures next. Anyway, so this website downloads these files. It creates, I don't know if I should show this. I think I will show one because I think it will be, I think it's worth showing. So this is what the website looks like. And so isochrono interpolation, I'm using a log 10 scale. You can put it a single age in, I'll say 100 million years, which is 10 to the 8th years. You put an 8 there because it's a log 10. If you do a linear scale, then you have to put it in actual years. And then you can put in some rotation. There's very restricted rotation information because rotation is not very well understood. Then there's some compositional changes you can put in, like how heavy you want the element. In other words, how much metallicity you want in the star to a certain extent. And then there's different output opportunities as well, or different levels of information. Click Generate Isochrones. The computer back up at the Harvard Center for Astrophysics is working for us right now. Click. Download. And presto, you have a big file of isochrones, which you can open awkwardly. It looks like this. And this is basically what the hell. Okay. Well, I think this one should be actually 163, not 162.
Yeah, I was wondering about that.
But anyway, so that's just what the website looks like, and it's very cool, and you can do different things with it. But back to this, so this is my Python code in a Jupyter notebook for downloading 3 isochrones. And again, the young one, this is 10 to the 5.5 years. Everybody's on the main sequence. They're just chilling. Their hydrogen core is burning. Everything's good. Life is steady. 10 to the 8th, the big heavy stars start to turn off the main sequence, head into that well-known giant branch, and eventually even scoot down to white dwarfdom. 10 to the 10th, even more. So what's fun, of course, is to, this is the information that you get, by the way. You put in the mass, you end up with the star mass, the derivative of the mass, notice how fast it is losing mass, and luminosity, etc. I won't go through all these. And then, so here's my HR diagram, and it's all very cool. So just look at the blue line. I was unable to figure out how to label these properly in the time I had with my level of limited expertise. So the blue line shows essentially a complete main sequence. And that's a young isochrone. In other words, you plop these stars down, put them in the zero-age main sequence, and they're all still there 10 to the 5.5 years hence. It's like they're just getting into their adolescence. But 10 to the 8th years, the big heavy ones that were up at the upper left of the blue line are now, they burned themselves off the main sequence, and they're starting to do hydrogen burning, the triple alpha process in the core. And the heavy ones are no longer on the main sequence, they've turned off. And then there's some horizontal branch activity, but I'm pointing on my screen, which nobody can see, but it makes me comforted. And then some of them are scooting over even to the white dwarf area. So you can see how they turn off the main. This is how you age things like globular clusters, by the way. You look at where they fall in the main sequence. And then for an even older isochrone, 10 to the 10th years, there's very little of the main sequence left. And what's left are basically the cooler stars, which tend to be smaller. I mean, the smaller and cooler are sort of interchangeable. Not quite interchangeable, but they're similar in stellar physics. So here on the green line, there's even fewer of the stars left on the main sequence, and they've all pooched up into the giant branch. So those are isochrones. Now I'm getting a lot of personal chat saying, Rick, that's really interesting, but what happens as a function of time? I want to know what happens as a function of time. So you can also make evolutionary tracks, which means as a function of time. Oh yeah, those chats keep coming in. I'm going to show you, everybody. Just hold your horses. So here, again, AstroPi, by the way, is like, Python has all these very annoying like packages and stuff. It totally blows my mind, but AstroPi is an astronomy one. So again, this all looks very sanitized, but this is agony. Not as much agony because I did it after the other isochrone thing. So now what this is loading evolutionary tracks for different size stars. Okay, so here's age on the horizontal axis and core temperature on the vertical axis. So let's look at the blue line, or let's look at the yellow line. That's one solar mass. So what's going on here? Well, it's condensing, getting hotter and hotter and hotter. And then, finally it's hot enough for hydrogen to start burning. So now it's got a nice stable time on the main sequence. Isn't that awesome? Runs out of hydrogen, triple alpha process starts, helium burning goes nuts in the core. And so in a very rapid amount of time, in other words, the age doesn't change much, it turns north in temperature, gets really hot. You look at a heavier star, same thing, only again, they live fast and die young. So here it is, main sequence much shorter than a 50 solar mass star. This occurs even earlier in its lifetime. So you see all the nice features of stellar evolution with these codes. Here's one with central density. I won't go through the steps, but central density looks very similar to central temperature. You get all this data and much, much more from the isochrones. I mean, from the output from the software. And the age, effective temperature is surface temperature, which is quite different, as you know, from core temperature. So let's look at and this is very nicely illustrated here. So the 50 solar mass, the red line, okay, it gets hot kind of fast. It's a big condensing mess of protostar. Helium starts burning, awesome. Now the core went nuts. It got really, really hot. There it goes. Well, here it goes. This temperature. But wait a minute. We think of these as red giants. Well, red means the effective temperature is cooler, and in fact, the effective temperature is in fact down In other words, a lower effective temperature leads to a redder color, as we know. So that's reflected accurately by the model, even though the actual core temperature is going crazy with helium burning. You know, other stuff too. This is central density versus central temperature. Nutty stuff happens here, but it all comes out of these models. I don't have a physical understanding of this. The rest of this here is main sequence. Anyway, that's all I wanted to say. I'm done. I'm just telling you that this is how I spent my summer vacation. Stellar evolution is very cool. There's some codes that help you do it. And I don't know, I find this incredibly enjoyable as an adjunct to looking at these stars. It kind of boggles your mind, at least my mind, when I think about these. You look up at the star, Vega, say, or whatever you want, and think of that as having once been a gigantic cloud that really did collapse according to certain physical laws, really did start to burn hydrogen in the middle according to physical laws, and it's just chugging away there. It's an amazing thing, I think, to just look up all these little points of stars that all condensed out of a primordial hydrogen mess. And it's like raisin bread. I mean, we're in the dough, and there's all these little condensed raisins everywhere that are the stars. That's sort of like the currency of the universe, it seems. We're sitting here on Earth, and we think that everything we see on Earth is what the universe is, but it really isn't. It's the little condensed messes of fusing hydrogen and fusing helium and heavier elements, and then turning into these cinders. That's what the real universe really is. It's kind of mind-boggling. If it were science fiction, it would be an amazing movie. That's it.
Cool. Thanks, Rick.
Also mind-boggling is to think about how the atoms in your body were created in previous generations of stars.
Yep, we are star stuff, like our dear friend or dear dead buddy of Cosmos used to say. Absolutely.
So Rick, there were a couple of things in the comments. Before I get to them, I just want to say the AstroPi or AstroP, I never know how to pronounce that, is a module I've used before for plate solving. It's got some very nice routines in that module. But Python isn't particularly my favorite language. I prefer using C++, JavaScript, and Java. Python, if you get one space wrong, it messes the whole thing up. So,
well, I think it's bizarre to have do loops or for loops that are spacing dependent instead of having a nice convenient end end thing. I think it's insane, actually. But if they didn't ask my opinion when they sort of made it the lingua franca of astronomy, I use Matlab in my day job, and to me, Matlab is almost like, I mean, I'm not like a power user, but I can do I can eventually get anything done. But Matlab is like Fortran. I mean, it's how you think. It's very logical. Python's a disaster.
Yeah, the issue I have with Python is I'm sloppy in my coding with spaces and tabs. And if you make one mistake, it just doesn't run. And it's very hard to find the error. Whereas things like JavaScript and Java and C++, they don't care. You can put as many spaces and tabs and returns, and it really doesn't make a difference. Yeah. So every time I've tried to use Python, I've gotten really frustrated because I can't see the mistake. Because to me, a space and a tab look very similar.
I actually asked some of the people in my group who are knowledgeable, because we're doing stuff that uses machine learning. I really just said, okay, so for all the programming, I don't get it. What is the advantage of Python over Matlab? And the answer I got, these are from the math students that I work with at College Park, it was a very good answer, which is they know what I code. I mean, they know what I personally code. And for everything that I do, Matlab is at least as easy or easier. So that's why I don't understand the beauty of Python. But for a lot of list-oriented programming, which I barely know what that means, I just say it, non-numerical lists, a lot of, I guess, different kind of array operations, and certainly a lot of machine learning manipulations, Python is the way to go. Since I don't personally do that, I don't do it with my own two little hands, I don't see the advantage. But
I don't either, because it's also an interpreted language. It doesn't get compiled, so it's much slower in terms of running the code.
Yeah.
All right, so real quick, the questions. One of the questions that came up is they wanted you to explain isochrone.
Isochrone means same time. So if you, you set off a whole bunch of, a range of stars of different masses. So, okay, time zero, I've got like a zillion stars across a spread of masses. Okay, so I've got 0.5 solar mass, 0.6, 0.7, 0.8, all the way up to say 50 solar masses. And they're all sitting there where they belong on the main sequence. And then you press a stopwatch and it rapidly moves up to say 100 million years. So they've all aged by 100 million years. And isochrone means look at everything at the same time. Iso meaning the same, chrone meaning chronologic or time or something like that. And so these, what that means is that you look at the main sequence, say, and according to an isochrone, and you see what happened at a certain time, given time for all those stars. Is that, I don't know. Yeah, so this is a series of isochrones, meaning each color represents that whole stellar population from 0.5 to 50 solar masses, and what it looks like on the HR diagram after, you know, these various number of years, 10 to the 8th, 10 to the 10th, or young, 10 to the 5.5. And again, this is how you look at, if you make an HR diagram, for example, of a globular cluster, you can assume that the globular cluster stars were all on the zero-age main sequence at roughly the same time. Namely, they collapsed, you know, they condensed, I should say, from the protoplasm of the interstellar miasma as protostars at the same time. So if you look at the diagram, let's say it looks like the orange one, you know, it turns off at a certain effective temperature and luminosity, then you say, oh, that cluster is about 10 to the 8th years old. Or if it looks like the green one, well, then it's 10 to the 10th years old. Or if it looks like the blue one, you really have no idea because it could be very young, or you know, there's not, everything's still in the main sequence. So there's a lot of downtime there where you can't really age them.
There was another question here. Hold on, what was it again? Oh, what's the amount of mass divided by gravity needed and hydrogen for a star to start fusion? I assume that means how massive does a star need to be in order to start fusing hydrogen?
Oh, well, I think the lower limit for an actual fusing star, and others can correct me if I'm wrong, is somewhere in the range of 0.3 solar masses.
0.3, okay.
And that depends on composition. It depends on rotation. Rotation tends to decrease the internal temperature because there's other pressure, well, there's centrifugal force basically that opposes pressure. So there's some fluff in there, but it's around 0.3 to 0.5, and someone can correct me if they would like to.
Well, I responded to him and said I wasn't sure, but I thought it was somewhere near 0.7, I think.
No, lower.
But
Get Jupiter otherwise. Otherwise, you get something like Jupiter, which isn't fusing. It's generating some little gravitational heat, but it's no one's going to go around, even its mother wouldn't call it a star.
So 0.3 to 0.5.
Yeah.
Okay. I think those are the only questions I see.
Okay, great.
All right, Rick, thanks again, man. Appreciate it.
Thank you very much.
All right, and next up is Bill Hanagan, who's going to share some photos.
Okay.
All yours, Bill.
So, can you see it? The titles?
Nope.
Nope. Oh, I see. Okay, hang on. Are you seeing it now?
Yes.
Okay, great. So, gotta rearrange some of these unwanted windows a little bit to get out of my way. There we go. All right. So I'm going to talk about some images that I produced from data that Rick Spencer and I have collected jointly over the last 6 months or so. And we'll start with the trio in Leo. And going from clockwise at the top right, that's M65, M66, and Hamburger Galaxy NGC 3628. So I'll give you just a second to look at that. Anyway, it's interesting to see how much difference there is from one galaxy to the next. It's always a little bit of a surprise. For example, as I worked on this image, I discovered there's just not much color in M65. But M66 has got blue star-forming regions and some red areas where you've got a lot of hydrogen alpha emission and much brighter core that gets dimmer. And of course, you've got the edge-on view for the Hamburger galaxy. So go on, the next is M106. That's the prominent galaxy here. There actually are 6 other fairly prominent galaxies, as well as 42 less prominent galaxies in this image. So let's see, there's a view of it. Okay, and here are the identifications. So every one of these with a circle and a green tag is actually a galaxy here, and there are several with yellow NGC numbers as well. And zooming in on the 2 largest galaxies in that image and upping the saturation a little so you can see the color variations. That's M106 on the left and 4217 on the right. This is my favorite from this time period. It's M51. A lot of these galaxies are actually quite small, which is unfortunate because it means there's a limit to how much detail you can hope to record. And with something this small, you have to go wait till there's at least the average seeing or better in order to get good detail in the galaxy. Okay. And so I'll zoom in here a little bit. And in this particular galaxy, the cherry red features here, those are high hydrogen emission areas picked up with a H alpha filter. You can actually pick up a lot more than that if you really spend a lot of time acquiring that H alpha data. I didn't do that, or we didn't do that. Let's see, and of course this is one of those galaxy pairs where there's pretty obvious, maybe even the strongest example out there of mass being pulled away from one galaxy into another. Okay, here's NGC 4565, which is mostly famous for the edge-on dust lane view. And I framed it this way just for fun because there happens to be a galaxy perpendicular to the NGC 4565. That's 4562 down here. And so it's a little reminiscent of the mothership. So we can call that the mothership asterism, except that there are no stars, and you need a big telescope to see the little galaxy. A couple of other little galaxies there. Okay, this is another group of galaxies. NGC 4725 is almost like a single spiral that's been kind of chopped up and turned into a ring, and then there's a much fainter outer ring. I'm not sure if everybody will be able to see it, but it's probably more visible on the left side than the right. 4712 looks kind of like a saw blade in space. And then 4747 is one of the Halton R peculiar galaxies. And of course, it's asymmetrical, but also if you look, there's a very faint glow of, I guess, ejected stars, or stars that have been pushed out or left out of the normal symmetrical pattern of the galaxy. Can people see that? Jeff, can you see that? That bow of stars in there?
Yes, it's faint, but I think it's there.
All right.
I can see it.
So we'll zoom in a little bit on 4725 and for a second. Okay. And the last image I'll show you is M20. This is the Trifid Nebula. And this particular version has blue somewhat accentuated here, so you can see more of the extent of the blue reflection nebula. It actually wraps around up here to the north side. You can see a little bit of on the, or excuse, not north, but the top. Okay. Now, generally, hydrogen emission nebulas are bright red because the H alpha line is solidly in the red part of the visible spectrum. So you might ask, well, why is this one so purple? And the answer is that a very large part of the nebula, besides being hydrogen emission, is also a reflection nebula. In fact, the brightest part of the blue reflection nebula is the part that's directly underneath or coincident with the hydrogen emission nebula. So that's why the red area is not just solid red. But if you'll notice also, this is a little bit bigger. The hydrogen emission nebula is bigger than the reflection section of that same area. And so when you get out to the edges, you expect then the color to shift over to a deep red. This image has been color balanced using the G2b stars that are in the image, so that the stars are all correctly color balanced, and that's cut away some of the blue, so you don't see the blue part of the nebula as well. But you can see in the red area that the transition from almost white, which is of course a mixture of the red emission nebula plus the blue reflection nebula, and a little bit of green thrown in, because the reflection, although it's not as strong in green, there's still a significant amount of reflection there. And that transitions through the reddish purple and then to a solid deep red where only hydrogen alpha is determining what the color is of the nebula. Okay, so any questions on this part?
Nice
Okay.
job, Bill.
Yes. So that's that. I have also a video from a few years back in the Eclipse that I thought I'd run since didn't get a chance to do that back in 2017. So let me full screen it. And I'm picking this up just before the eclipse starts. You can see the coloration changing in the clouds here in just a minute. Jeff, are you seeing this okay?
Yep. It's a little choppy, but it's not too bad.
Is this video from your phone, Bill, or what?
Say that again.
Is this video from your phone? Your camera was stuck into the telescope, as I recall.
Well, this is a video camera of my brother's. We set up on a tripod to take the video while we were all doing the eclipse things.
Okay.
And while I can't guarantee this guy actually saw shadow bands on the tent, I can say everybody else there saw shadow bands on the concrete. So you'll notice it's gotten dark in the distance, getting progressively darker.
This is awesome. It really brings back that memory.
Where'd you guys go?
This is Carbondale, Illinois. Rick was here with us, as a matter of fact. Originally, Rick was set up to go to St. Joseph, Missouri, wasn't it?
Yep, that's right.
And it rained there, so he came back along the path to the east. We connected up by cell phone.
I drove like crazy for hours, and then I remembered, oh, Bill's somewhere. So I called him. And
Nice.
actually, Bill, were you using your cell phone at the time? How did I get you?
I was using a cell phone at the time, yep.
Oh.
Cool.
Is that loud enough?
Cannot hear the audio.
Yeah.
I can hear it. It's pretty faint.
So that's pretty much it there.
That's great. We came very close to not seeing it. Remember the cloud that moved left instead of right? If it had moved right instead of left, it would have been nothing.
Yep.
Incidentally, the picture that's my background right now, I took it from not that far from where you were on the same day.
Oh, you took it the next day.
What?
I'm trying to get my screen back here. Let's see.
We're seeing your desktop.
Okay. Well, let's just unshare it then.
Still seeing your desktop.
Yeah, sorry. How do I get out of that? Anybody got a quick fix?
Oh, you should be able to click at the top on stop sharing.
You got it. Cool. Any questions for Bill?
Oh, sorry. Was I muted the entire time?
No.
No, okay.
No, it just happened.
Okay, good.
All right. Well, Bill, thanks a lot. That was great.
Thank you.
Nice job, Bill.
Yeah, thank you.
So those are all the talks that had been volunteered ahead of time. I mean, you know, it's about 20 till 10 right now. Does anybody else have something maybe brief that they'd like to share? Otherwise, we'll close out the meeting for this month.
Just real quick, guys, I don't know if you've noticed how hazy it's been and how hazy it's going to be. It's for the California wildfires. Particulates have gotten all the way east from like I think as far north as Connecticut to as far south as Kentucky.
Yeah.
Due to, the jet stream and the prevailing westerly winds and stuff. But take a gander at the sun, at the sunrise, at the sunset. It's noticeably hazy. Not good for astronomy at all.
Or the planet even.
No, yeah, that's for sure. Hello, nuclear winter. Say again?
I heard that it's going to cool off.
The planet in general?
Too much global warming.
No, President Trump said that it would cool off.
Well, see, the wildfires are helping with that, so it's great.
Yeah.
We're fine.
Cool.
It's all good.
Yeah.
Anybody else have something that they'd like to share?
Yeah, I could share something real quick.
Go for it, Rob.
So earlier this summer, I did a bunch of astronomy stuff, but I already shared most of that. The last 2 weeks, I've been working on a project for my students, which you guys might be interested in. I've been developing a sandbox simulator that should work on all their devices, no matter if they have a phone, computer, doesn't matter what kind of computer. As long as they have an internet connection, they should be able to use this and actually be able to conduct their labs. So they can set up a lab in this simulator. They can put objects in there. They can add things like rotations or angles to them. They could fix things in place. Maybe take this, put this on top of that, and then when it runs, it'll go down that. And then you
That's
could
cool.
simulate it.
Very cool.
Select
Yeah.
data.
I like it.
That's neat.
Here,
Yeah.
position versus time data for that ball,
Jeez.
Oh, wow.
which the students can then click this button, download
Wow.
it, and do their little analysis on their computer of that object.
I remember putting that down manually.
Yeah,
They want to,
that's really nice.
Mm-hmm.
they could do something like this with an object that has harmonic motion,
Wow.
steady circular motion and simple harmonic motion. If we decided to graph that, say position versus time, let's say in the X direction only, should be kind of harmonic.
Oh, wow.
Whoa.
We need to get this into grade schools, get more scientists involved.
Well,
Yep.
this is on the
Right
internet.
here.
Like anyone with a web browser can go to this.
Viz,
That's my
viz.
goal, is to make it public so that people can just do it. Because everybody's stuck at home, why not make it so that we can actually do some labs?
Wow.
Hey, Rob,
Yep.
can you simulate slingshotting pigs into a pile of birds?
Do you have an image of the pigs? Because if so, then the answer would be yes.
I know a game, slingshotting birds into pigs.
They have to be angry though.
Yeah.
There you go. That point true.
So, Rob, I noticed in that harmonic motion that was damped. Is that?
Yeah, that had to do with drag being turned on, I think.
Okay, so it's air drag or
Yeah, I
fluid
believe
drag?
it was air drag that was influencing it. Sure.
So Rob.
Yep.
As an educator, and I guess the other educators here as well, Matt or anyone else, since I'm an old timer, I'm very uncomfortable with students learning, well, say simple harmonic motion and whatever, you're showing some gravity stuff through simulations, as opposed to putting their hands on a pendulum and rolling a ball bearing off a piece of wood, etc. I mean, of course, more sophisticated things. So you can simulate anything. You can do away with an oscilloscope. You can do away with circuits. There's oodles of programs that create electronic circuits for you.
Yep.
I don't know.
So I can tell you from experience, because I've been doing this for 15 years now, I can tell you the most important thing is to have students set up the lab themselves. it's not so much important whether it's a virtual lab or a physical lab, but it's really important that whatever it is, they design it, they set it up, they experience it. So like a lot of these things you find on the internet, there's many simulators online, but virtually all of them, at least for kinematics and forces, are set up in a way that you just click a button and it goes. You know, somebody else has already created it and you just watch what happens. Whereas what I'm trying to make here is a sandbox. It's called a physics sandbox, where people sit down and just make the experiment they want to do. Their mind is the limit for what the simulation can be, and they can actually do a complete lab. Like they can set it up to collect data, say position versus time, say the height versus the distance, or any number of different labs they might want to dream up and try. We've often used a sandbox like this in class on the computers that were there, and it was installed on the computer. But the students don't have access to that during the coronavirus. They can't use those programs. So I had to real quick come up with something that they could use to collect data, set up some experiment, and get some results that they can analyze. Because otherwise they're just watching videos and demos and simulations that are already predetermined. They can't like create their own.
It makes total sense during the pandemic time and it sounds like you did an incredible job of doing the best possible, but you're saying it's important to have them set it up themselves. But I just wonder, again, I'm not an educator, but it seems that setting up a computer experiment is just fundamentally different from setting up an experiment with resistors and capacitors and whatnot.
I would call them complementary. So I often use the simulator in class, but not for the primary instruction. It was another thing I had them do. So I have them set up a lab here, design a virtual lab there, set up a virtual lab here, do a real lab there. I changed it up. You know, it's complementary. It's not supplementary. You can't replace everything with a virtual lab.
Certainly not dropping things.
Yep.
Very good, Rob.
Yep.
Yeah, really cool.
Amazing.
Some of the electronic technology courses from the colleges, like the homeschool type of things, have similar things with electronics where you do all kinds of circuits and experiments like that.
Yeah, there's quite a bit with circuits. There are great simulators for circuits.
Yeah.
There's not really any good ones for motion unless you want to download a program that runs on your computer.
Right.
There's one called Interactive Physics that we used in school, and there's one called Algodo that we used in school. But neither one of those work on all devices.
Any optical stuff?
There's a couple of good simulators for that. There's one that's a jar file running Java. There's one, Algodo does that. It's a simulator we use, but it doesn't run on all devices either. But no, I'm not currently putting optics into this simulator.
Okay.
This is going to be a mechanical simulator.
Right.
Doing just Newtonian physics, collisions, kinematics, dynamics, circular motion, and probably gravitation.
Yeah, I had fooled around with some ray tracing programs and things like that, but you know, things like interference and diffraction, things like that might be something interesting to at least simulate, because some of that stuff is, you know, more sophisticated than say a mechanical experiment setup.
Yep. Yep, and there are some good simulators for that too.
Yeah, especially for home, you know.
Mm-hmm. Yep. Any other questions? That's what I got.
I should perhaps mention, and I probably should have done this earlier, but the next AP SIG meeting is Saturday at 1 o'clock. For those of you who...
This Saturday?
Yep.
I won't be there.
Sorry to
I'll
hear.
probably be there.
All right. Well, again, I'd like to thank all of our speakers again tonight. That was really great and a diverse program. Just a reminder to everybody, the next couple of Tuesdays, we will do our casual, informal astronomy workshop. And then the second Tuesday of October will be our board meeting that board members are highly encouraged to attend, but all members are welcome. And then the third Tuesday will be our monthly meeting. I don't have a speaker arranged yet, but I will figure out something in the next week or two here. And then as always, keep your eye on the DAS groups.io or spur on some discussion on the groups.io. One thing, again, that was mentioned at the beginning is, especially coming into this fall season, which is my favorite time for outdoor observing because it's good weather, it gets dark, it's dark at a reasonable hour. So keep your eye out. We're trying to figure out a way to do some, not outreach, but, member star parties. I'm currently in chats with Fairhill Park to see if we might be able to do something out there. There may be some restrictions, there may be some limitations, but something is certainly better than nothing, and I think that's the name of the game these days. So again, thanks again to everybody. Great to see everybody else, and hopefully we'll see you soon.